everybody, we're doing my favorite lesson today. So we're doing the distance formula. And you'll see why it's my favorite lesson in just a couple minutes. So first, we're going to do the opening exercise. So we've got 3 points, which makes a triangle. And we're going to determine the length of a couple of the sides. So DE is this piece right here. We can figure out the length of that just by counting the boxes. So if you start at E and you count up, it's going to be 8 boxes. So that is going to be 8 units. And then EF, you do the same thing. You start at one point, go to the other, and that's going to be 6 boxes. So the length of EF is going to be 6. Now, we couldn't figure out what the length of DF is just by counting the boxes because these diagonal pieces here, that's not a full unit. That's not the right way to count these. So if we wanted to figure out the third side of this right triangle here, then we can do Pythag, which is why this is my favorite lesson, because I love Pythag. So we can do Pythag because we know that those two, DE and EF, are going to be perpendicular, which means we've got 90-degree angles, which means it's a right triangle. The reason we know that, there's a couple things. First one that you could do is you can do the slope of both of them. And then when you do the slope, you're going to see that the answers for the slope are going to be negative reciprocals of each other. And that means they're going to be perpendicular. But also, you could tell that DE, that's a vertical line, and EF is a horizontal line. And if you've got vertical and horizontal, those are always going to be perpendicular. So since we know that it's perpendicular, 90 degrees, which means it's a right triangle, and we've got 2 side lengths, we could figure out the third side length. So we're going to use the Pythagorean theorem, or Pythag, to figure out the length of DF. So just to review on that, that's going to be a squared plus b squared equals c squared. A and B are going to be the 2 sides that touch the right angle. So it doesn't matter which one's A and which one's B. But C has to be the one that's across from the 90-degree angle. So you're going to plug those in and figure out what C is. So we've got 6 squared plus 8 squared equals x squared. And x is going to be DF in this case. So that means we have 36 plus 64 equals x squared, which is 100 equals x squared. To get rid of the square here, we have to do the square root. And whatever you do to one side, you do to the other. So that means we have 10 to equal x, which means that segment DF is going to be 10 units long. So we can use that to figure that out. But what if I had the question of the length of DF, but I didn't give you point E? Okay, if I just wanted the length of a segment that was diagonal. Now you could always take that diagonal line and turn it into a right triangle and do Pythag. But today's lesson is the distance formula. It's going to be like a shortcut for Pythag. Okay, so this is what we're going to do. This is the formula, and I know that does not look like the nicest formula ever, but it's secretly Pythag. It's Pythag in a Halloween costume because it makes it look worse than it actually is. So let's kind of talk about how this is Pythag first, and then you'll get used to what this formula actually is. So let's see. If you were going to be doing Pythag, right, and you had a triangle like this, and you had a right angle, you had A and B and C. When you do Pythag, a squared plus b squared equals c squared, and you were looking for the diagonal line, C, if you wanted to get C all by itself, you would have to get rid of this square here, so you would do the square root of both sides. So that means that the length of the diagonal line, that distance, is going to be equal to the square root of the lengths of the other sides squared and added together. This whole thing. Now, that looks pretty close to what this is. It's the square root of something squared plus something squared. Now, A and B in these cases are going to be the difference in the x's and the difference in the y's. Oops. Okay, so if you have the x values, if this was on a graph, A is the difference in the two x values here, B is the difference in the two y values here, and you're going to end up getting the same thing. So I'm going to show you that again with the next example, and then we're going to talk about how that's Pythag, but then if you want to just use this formula, that's the shortcut version. That's the way that is always going to work when you're given coordinates. So first, let's look at this. We've got 2 points, 2, 8, and 8, 6, and we want to figure out the distance between the 2 points. So if you want to do Pythag and you graphed this, you can take this line segment here and make that the hypotenuse of a right triangle. To make it the hypotenuse of a right triangle, though, you need to have 3 sides all together, and 2 of them need to be perpendicular. So the 2 perpendicular sides that you're going to have, one of them is going to be vertical and one's going to be horizontal. So if we make this into a triangle, we're going to extend one side down and extend the other one in this direction. That way we've got a right triangle. So the left side over here, that goes from 6 up to 8, which means the length here is 2. And then for this piece, it goes from 2 all the way to 8, so that means the length here is 6. So if you wanted to figure out this distance over here, which I'm going to call that D in this case, this distance of the diagonal line, you could use Pythag. So 2 squared plus 6 squared equals D squared to figure out what D is. Okay? But you could also get the exact same answer by doing it with this formula up here. So for that formula, I'll put it like this. We've got x1, y1, x2, and y2, and we're going to plug it into the formula from above. So D equals the square root of the difference in the x's squared plus the difference in the y's squared. So when you plug this in, we'll do the difference in the x's first. We've got 8 minus 2. And then the difference of the y's, we've got 6 minus 8. And we have the square root of that whole thing. So 8 minus 2 is going to give us 6. And then 6 minus 8 is going to give us negative 2. Now, all of the negatives that you get here are going to go away because you're squaring everything. So we're going to end up having all positive numbers. So the distance is going to be equal to the square root of 6 squared, which is 36, plus negative 2 squared, which is going to be 4. If you put that in your calculator, make sure you keep the parentheses so that the negative is squared also. So the distance is going to be the square root of 40. Now, if you did the same thing over here with this, you'll get the same answer. You're going to get 4 plus 36. So that's 40. Square root both sides. You've got the square root of 40. Okay, so you are going to get the same answer, but when you do the formula, you don't have to draw the picture. You don't have to think about it quite as much. You're just going to plug in the numbers. One more thing with this, it says to put it in simplest radical form. So that means you're going to take that 40, square root of 40, and you're going to split it into 2 different square roots. So the first one is going to be the largest perfect square that goes into it, and then the second one's going to be another number, but it's going to be so that the 2 numbers that you've got in here and here are going to be multiplied together to equal 40. So 4 is a square root that goes into, or a perfect square, sorry, that goes into 40. And 4 times 10 equals 40. Square root of 4 equals 2. And then we're going to leave the 10. So this is our answer. But if it didn't say simplest radical form, it's still equivalent to the square root of 40. So if you want to do the distance formula when you've got coordinates, it's one of the ways that's more straightforward. You just plug into this and you're going to get the correct answer. But if you are more comfortable with using the Pythagorean theorem and you have a graph, then you can still do it this way, but it's just going to take a little bit more time and there's more room for error. So I'm going to do example 2 by using the formula. So we've got these 2 points that we're finding the distance between them. So we've got x1, y1, x2, y2, and we're going to plug into this formula. So that is the distance equals the square root of the difference in the x's squared plus the difference in the y's squared. And then you're just going to plug in. So we've got distance equals the square root of difference in the x's squared plus the difference in the y squared. So x1 is negative 10 minus x2 was negative 10, sorry, and x1 is negative 5. So we've got minus a negative 5, which is plus 5. And then y2 is 2 minus y1, which is 12. So the distance is equal to negative 10 plus 5, so that is negative 5. And then 2 minus 12, so that is negative 10. So we've got 25 plus 100. So D equals the square root of 125. And then we can reduce that into simplest radical form. So that is going to be 25 and 3. No, 25 and 5. And then we've got that equal to 5 square root of 5. There we go. And that's going to be our answer. And if you wanted to double check that by doing a picture like this, you could. But this is a way that's always going to work as long as you don't mess up on the algebra part of just plugging in here. Sometimes they don't ask you the exact same type of question where they just want the length of one segment. Sometimes they ask you for something like maybe the perimeter. So for this next example, it gives you 3 points, which make a triangle, and you want to find the perimeter of that triangle. So when you do the perimeter of any triangle, what you're doing is you're adding up the lengths of the 3 sides. So if we took the triangle that we had here, we have the 3 sides. The first one I'll do is OL. So you're going to find the length of OL. So that means you're going to use the distance formula with these 2 sets of points and figure out the length of it. And then what I want you to do after that is to add that to the other 2 sides. So you're going to also do LD, find the distance between those 2 points, and then your answer to the last one, which is OD, you'll add all 3 of those together. So you're going to do the distance formula 3 times here. So you're going to do the distance of OL, which you're going to have the whole problem like this. You're going to do the distance of LD, and you're going to do the distance of OD. So you're doing this whole problem 3 times, and then you're going to take your answers and add them all together. And that's going to be your perimeter. So what I want you guys to do for right now is I want you to pause the video and try your best to do that on your own first, and then I'll show you the answers in a sec. So these are the answers for it. you're going to plug into that formula. And for OL, this was our answer. For LD, this is our answer. And for OD, this is our answer. And then you're going to add all three of those together, which I did right here. And we want it in simplest radical form. So I split the 20 into these two parts, 45 into those two parts, and then 17 doesn't split into anything. And then you can do like we did in the beginning of, wasn't the last unit, 2 units ago? And we can combine like terms. So the 4 becomes a 2, square root of 9 is a 3, and then just like 2x plus 3x equals 5x, 2 square root of 5 plus 3 square root of 5 equals 5 square root of 5. And then this plus square root of 17 just kind of hangs on the end. So this is our answer for this one. If you got that, that's great. If you got up to here though, then that's also really good. Okay, if you can get up to that point and you got these 3 numbers, then that's what you're supposed to learn from this lesson. For example 4, I'll show you the blank one first. We've got a couple different problems here. The first one says that we've got an isosceles triangle with these as the points, and we want to use the distance formula to prove that the 2 segments are going to be congruent. So whenever you have an isosceles triangle and 2 sides are the same, in this case we've got CA and CB, so we want to prove that this is the same length as this. So you're going to use the distance formula to find the length of CA, and you're going to use the distance formula to find the length of CB, and you're going to just prove that they're the same length. So that just means that whatever your answer is for one of them is going to be equal to the answer for the other one. And that's going to answer this first part. The second part is using the distance formula to determine the area of this triangle. So to find the area of a triangle, it's half of the base times the height. So the base is going to be this, and the height is the altitude. So we would have to find out this as well. And the altitude is always going to be perpendicular to the base and go through the vertex. And it says that that's going to intersect at point P. Right here, I'm calling it P. And it tells us the coordinates for that, so we don't even have to figure out this right here. Okay, it tells us it right here. So we're going to find the length of both the base and the altitude, the height here, and then we can plug that into the area formula. So let's do the answer for that here. The first part is proving that these 2 are congruent. That's all right here. So CA is the square root of 58, and CB is also the square root of 58. So since they're both the square root of 58, that means they are congruent to each other. Okay? And if you could do that on your own, that's great, that you could plug into the formula, and we've got that. And that's pretty much what our proofs are going to be from here on out for this unit. They're not going to be the same way we did proofs before with the table and the flowcharts and all of that. Our proofs are going to be more based on numbers now. The second part with the area is what we've got over here. So to find the area or the distance of the base, which is AB, we do this, which gives us 4 square root of 2 as our number. And then also the height, which is the altitude right here. I put point P on it, that way I could say that this is the length of CP. So then we plug into the formula and we get 5 square root of 2. I reduce these. You don't have to reduce them. You could also use square root of 32 and square root of 50 if you'd like, but I made the numbers smaller because that was easier for me. So now you're going to plug into the formula. So area equals half of the base times the height. The base was AB and the height was CP. So we plug in that. And then when you multiply, that'll out if you put the whole thing in your calculator, whether you used my reduced numbers or you used the other numbers from here, you're still going to get the area to equal 20. Okay? And we don't have units here, but if it was like inches, it would be inches squared because it's area and we have square units. So that's it for this lesson. We are going to use this formula a bunch in the future. So if you have any questions on this, please let me know. Also, the homework for this, it's 1 page. It's going to be due on Friday. That way, when we do a live Zoom lesson on Monday, we'll all have that done. I'll be able to give you feedback before we do the live lesson. That way, everyone's all on the same page.